Welcome to True Projects. In this video, we are going to explain about a project titled ML-based software design pattern detection and source code using the neural network. In software development, effective code management is a vital as code complexity grows. Design patterns provide a structured approach to organizing and comprehending the code structure. This project focuses on automating the detection of design patterns and source code through a machine learning methodology, specifically an artificial neural network. By leveraging the power of ANN, the project goal is to accurately identify and classify the design pattern in code, facilitating the improved code reuse and maintenance. The objective of this project is to create an automated system using the machine learning approach, specifically an artificial neural network, to detect the software design pattern and source code. The ANN will be trained on the dataset that includes various design patterns. The objective is to develop a model that can accurately predict and identify the design pattern in the new code. This approach aims to enhance the code management and promote code reusability by providing the insight into the presence of design pattern and within the code. These are the basic requirements that are needed to build this project. Operating system as Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirement Python IDEL with version of 3.7. These are the modules that are developed to build this project. The first one is upload source code dataset. Using this module, we will upload the dataset to the application and then identify the different designs pattern available in the dataset. And the second module is pre-process and normalize the dataset. Using this module, we will read each source code file and then build a numeric vector by replacing each word with its average frequency. And this numeric vector will be normalized using the min-max class and then plot the graph with different design pattern source code by count found in the dataset. The third module is dataset train and test split. Using this module, we will split the dataset into the training and testing part, where the application uses of 80% of dataset for training and 20% of dataset for testing. And the fourth module is run ANN algorithm. That is, 80% of training data will be input to ANN algorithm to train a model, and then 20% of dataset will be applied on the ANN trained model to predict the class label for test data, and then calculate the accuracy between the predicted and the test label values. And the fifth module is ANN training graph. Using this module, we will plot ANN training accuracy and loss graph with on the basis of epochs. And the final module is design pattern detection from the test code. Using this module, we will upload the test source code file, and then ANN will analyze source code and predict the design pattern from the uploaded test code file. And the execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files. The first one is design pattern files consisting of 4 folders that are abstract factory, adapter, factory method and visitor, each folder consisting of different files, different Java files within it. And the model folder consisting of this HDFI PKL files, which contains the algorithm information, and these files can be loaded into the project code during the runtime to utilize the trained model for various tasks such as making the predictions on new data. And the test code folder consisting of different Java files, which is used for testing the model performance. And the design pattern prediction, test and train are the main Python files, and the run is a bat file. Instead of executing the program in command line interface, we created the Windows bat file to execute the project. Now to run the project, double click on run.bat file. This is the graphical user interface. With this, we are interacting with the program. Now click on Upload Source Code Dataset button. By this, we are redirected to this folder, and we need to select the Design Pattern Files folder and click on Select Folder button. By this, we get a screen of design pattern file is loaded, and the design patterns consist of 4 gangs that are abstract factory, adopter, factor method and visitor. And click on process and normalize dataset button. By this, we get an graph on design patterns found in the dataset. That is, x-axis represents of the design pattern and the y-axis represents of each design pattern count. And close this graph, and here we can see the dataset is pre-processed by each one in the code is converted into the numeric vector by replacing with its average frequency. And here the dataset consists of 128 rows and 301 columns. First row contains the code word names and remaining rows contains the average frequency of those words. And click on dataset train and test split. By this, the dataset is split into the training and testing part, where the 80% of dataset is used for training and 20% of dataset is used for testing. Total records are of 128, and for training 102, and for testing that is of 26. And click on Run ANN Algorithm button. By this, we get an confusion matrix for the artificial neural network, where x-axis represents the predictor label and the y-axis represents the true label, and all different color boxes in the diagonal represents the correct prediction count, and the remaining color boxes contain the incorrect prediction count, which are of 0. And this close this matrix. Here by this we get an precision, recall, F-score accuracy for the artificial neural network is of 100%. And click on ANN training graph. By this we get an graph where x-axis represents of epochs or iterations and the y-axis represents of accuracy or loss value, where blue line represents of ANN loss and the green line represents of ANN accuracy. With increasing of epochs, the accuracy gets increased. And close this graph. And click on design pattern detection from the test code button. By this, it redirected to the dataset folder consisting of test codes, and click on here, select any one of this file, and I'm selecting this file and click on open button. And here the uploaded file name is diagram selection listener.java, and the detected design pattern is of adopter. In this way, we can detect the design pattern in source code by using the artificial neural network. In conclusion, this project demonstrates the effectiveness of using a machine learning based approach, specifically an artificial neural network, for automatically detecting the software design pattern in the source code. The developed model shows promising results in accurately predicting and identifying the design pattern, providing a time-efficient and automated solution for code management and promoting the code reuse in future software components.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.